Okay, suppose the odometer is broken and we want to estimate the distance driven over a 30-second time interval. We take a speedometer reading every 5 seconds and record them. Note, we first convert it to feet per second. Find the left-right Riemann sums to estimate the distance traveled. Okay, so I don't have a graph right here or a function, but I can use the x,y values to do the same thing. So the first thing that we note is that delta x is the amount of change in x. It appears to be 5. These are increasing by 5 each time. So delta x is 5. I can observe that. I took readings every 5 seconds, and so my delta x is 5. 5 seconds between each reading. Then we have our endpoint ordered pairs. So if I want left readings, I'm going to use the first grouping. So this is going to be 1, 2, 3, 4, 5, 6 again, groupings here. And when I want the right, I'm going to use second to last. So we have our left and our rights. And these are going to be the y values or the f of x k star values, just they are given to me. So for the left Riemann sum, we'll take our delta x of 5 times 25 plus 31 plus 35 plus 43 plus 47 plus 45. And for our right Riemann sum, I'll do the calculation for that one in a minute. And for our right Riemann sum, it's going to be 5 times 31 plus 35 plus 43 plus 47 plus 45 plus 41. Okay, equals, and we'll find out. So we're going to add up the left one first. Okay, so you can see what's going on. There we go. So add up the left one first. 5 times 25 plus 35. Hopefully I got all those typed in correctly. And if I copy that and paste it and take off the first one from the left, I can add on the last one for the right. Okay, so I'm hoping I typed those both incorrectly, hopefully, and then double check me. But I think that looks good. And so we have, for the left Riemann sum, a value of 1,130, and for the right Riemann sum we have a value of 1,210. Now, we don't have a picture for this one like we did for the previous one, or a function for that matter, so I don't know that this is all under and this is all over. I don't know. But what I do know is that they're both going to be approximate, and that somewhere between them or around one of them, it could be, if they're both over, it could be below the first one. If they're both under, it could be bigger than the second one. I don't know. But it gives me something that can at least help me estimate how many feet the vehicle traveled, whatever it was. It traveled at least 1,000, probably 1,100 to 1,200 feet. Meters. Feet? Feet. Okay, so let's put some feet on there. Okay, so it gives me two estimates that both estimate the distance traveled. Okay, that's all I know. Okay, so let's take a look at the next. On October 14th, Felix stepped off of a balloon capsule at an altitude of almost 39 kilometers above the Earth's surface and began free fall. His velocity in meters per second is given in this figure. It's claimed that he reached the speed of sound 34 seconds into his fall, and he continued to fall at supersonic speeds for 30 seconds. By Red Bull, apparently. So, divide the interval from 34 to 64 into 5 subintervals with grid points. What are the grid points? Okay, so I've got to find my delta x to get the grid points. So first of all, delta x is 64 minus 34 divided by 5. So 64 minus 34 is 30 divided by 5 is 6. And so the grid points are going to be so the grid points are the end points. So they are not going to be the things that I use for xk star. They're going to be the things that xk star is around or between. So the first one is 34, the next one is add 6, 40, then 46, then 52, then 58, then 64. So there are 6 grid points, even though there are only 5 intervals, because the intervals are between them. 1, 2, 3, 4, 5 between them. Okay, so those are my grid points. Okay, so since I don't have a function for this, I'm going to be using the graph. I'm going to draw the intervals. I'm going to pause so I can draw. Okay, so we have our grid points, again, the 34, 40, 56, or 52, I meant to say 58, and then 64. So those are our grid points. And so we want to use a left Riemann sum first of all to figure out how far he fell at supersonic speed. So I want to draw the rectangles for the left. So I've drawn the lines up for the grid points, but that's not the same as the rectangles. So if it's going to be a left Riemann sum, the top of the rectangle needs to connect with the left endpoint. So the left Riemann sum is going to have rectangles like this. If I'm connecting with the left endpoint, some of these rectangles are going to be underestimates, like the first two. Some of them might be combinations, like this middle one, and then some of them are going to contain space that is outside of the shape, like the last two. They're going to have a mix right here on this function. Since it has both increasing and decreasing, we've got a mix of underestimates and overestimates. My highlighter's a little low on ink, it looks like. Okay. So there we go. So we've got our rectangles. Okay. So it just said to draw them. Let me check on the next page to see if I want to. I think I actually want to use it and draw them. Good. Use it and draw them. So use it now. So use a left Riemann sum. It's going to be delta x 6 times. I need my xk star values. I don't know them, but I can guess them. So right here, this looks like this is a scale of, is it 20? So each of these goes by 20. And so this one might be, say, 310, since it's maybe halfway up. So we'll call that one 310. This one looks like, okay, so 320, 40, so 350 maybe. Again, we're getting halfway each to these, so that would be 370. This one looks like it might also be 370. And then this one would be at 3, see, could be at 350 again. I'm just trying to see if that looks like the same height. It looks like it might be 350 again. We'll go with it. Again, they're pretty rough estimates. Okay, and then, so what do we think? Let's calculate the sums here. So we need 6 times 310 plus 350. There's 2 of those, plus 370, and there's 2 of those. So I got a sum of 10,500. I don't know what I just did. There we go, better. Accidentally maximized. So a sum of 10,500, and our units here were in meters per second and second. So this is going to be in meters once I find the product of the two. That's in seconds. These are all in meters per second, so the product is in meters. So we're estimating that he fell 10,500 meters at supersonic speed, because he thinks he was at supersonic speed in the interval between 34 and 64 seconds.